Hi again, Captain Peter Cutsey with video number 4 in the South Briefing series. In the last video, the first officer accomplished part of the CDU pre-flight up to the N1 limit page and stopped there because at this point, none of the performance data had been accomplished. So what we can assume is from that point, he or she would have done their pre-flight procedure. So we'll assume that the first officer's pre-flight procedure at this point is complete. He or she has now adjusted rudder pedals, seatbelts, shoulder harnesses, and is awaiting the captain to initiate the performance. While this was happening, the captain returned from the walk around, got in his seat, did his pre-flight procedure, checked the CDU entries, as we mentioned before in video number 3, against the flight plan, and it was happy with all the entries that the first officer had made up to this point. At that time, the captain would then adjust rudder pedals, seat, shoulder harnesses. Now, this is the trigger, as per FCOM, to call for the first checklist, which is the pre-flight checklist. We'll assume at this point that the pre-flight checklist is complete. Now the captain will initiate the performance as per OPT. So let's go and have a look at a PowerPoint that I've done. And this is where we are, completion of the pre-flight checklist after both pilots have checked the ATIS. So we'll say that both the captain and first officer independently listened and copied. Important that it's done this way, not discussed, so that both pilots will hear information that they're going to put independently on their own OPTs. If they both heard the same information and copied it and entered it, then the calculations should match, and then we know that both pilots heard the same information. This is just one way of avoiding any errors. Good threat error management. All right, so we'll say that both pilots have copied the ATIS. The captain now initiates the first phase of the OPT by saying ready for the greens. Now let's just go and have a look at what the greens look like. He is talking about 9 greens, data that he will read and type in, and the first officer will follow through by repeating and typing it in. Those are the greens. And incidentally, these are the whites. The whites for this particular company happen to be the ATIS wind, outside air temperature, and Q and H. Okay, so that's the point that we're at. So airport OMDB captain would call it up, type it in, and the first officer would repeat and type it in by repeating it. Runway 30 right, runway 30 right, and so on until they completed the 9 greens. Then they would independently enter the 3 whites. All right, so that's complete. Once that is complete, that is pretty well the end of the first phase, unless you've actually received the final figures at this point. In many cases, you will have not received the final figures at this point, and the captain will initiate the other things that must be done, such as an ATC clearance and perhaps even the taxi and takeoff briefing, depending on time available. We'll assume at this point that the crew members have received the final load sheet, which for this particular company looks something like that. All right. And then we'll go back here, and the captain will take 2 items off of that load sheet and call them out and enter them in his OPT, and the first officer will do the same. After confirming that what the captain is reading, the captain will show the first officer the final load figures. So they'll both type in the actual takeoff weight and the percentage takeoff weight, MAC TOW. And then, providing they've entered the whites in the OPT, they'll get a blue calc, which means calculate, press it, and let the system work out the information. Once the calculations have been done, the first officer will record the takeoff data on the flight plan. And there's a special area on the flight plan, which is now the official document. So the first officer copies all the data on the flight plan. And then from then on, the first officer will be using that data for reference, and the captain will be using his OPT. After he's copied all the data that he could, there's a couple, one that we can't do, and you'll find that out in a second. Ready for the readback. Captain will say, go ahead. So the first officer will read everything that he's copied from the flight plan, and the captain will confirm whether that's what he's got on his OPT. If all the numbers match, it means what the captain heard on the ATIS, what the first officer heard on the ATIS, what they both entered on their OPTs were the same, and also the data on the flight plan, which is the official document now, all coincide. So, which means that that is proof that the data is correct up to this point. Now the captain reads the actual zero fuel weight from the load sheet, shows it to the first officer, and the first officer enters it. Well, let's go and have a look and see what it is. The actual zero fuel weight is 54,966. So the first officer will enter 54,966, overwrite the estimated, or in many cases blank, in any case 54,966, and stop there. No one will execute yet. The weight we're looking at here on the CDU is our current weight at the gate. We have to subtract the taxi and APU fuel from that in order to get the takeoff weight. All right, let's just go and have a boo at the takeoff weight. The takeoff weight was 75,084, rounded 75,100. So 75,100 is rounded. So let's go and have a look at 75,300 minus 200, 180 rounded up to 200. So 75,300 minus 200 is 75,100. Bingo. Figures check. Captain says to the first officer, execute. He does so, and then he follows the prompts and enters in, I've done it already, the assumed temperature and TO 26K with climb 2 give us 96.5. Well, we have to go over and check that. Of course, this is the time, the first time you're going to check it, you'll be checking it on the before start procedure later again. So here it is, DTO, 45 degrees, assumed temperature, and 96.5, 96.5. Checks. All right. Now, following the prompts, the first officer will go to the takeoff page and go to page 2 and fill in the surface wind from the ATIS, in this case 010 at 5 knots. And the slope, that comes from the airport information on the OPT for that runway, and it's a downslope. So downslope 0.2 as per OPT. /299 is set. NADP number 1, acceleration height, 2-engine acceleration height, 3,000 feet. For this airline, the thrust reduction at 800 feet. Now remember, these heights here are all above ground. Now, how do we get this figure of what we're going to put in here? We want to put in 808 feet here, and we get it by the actual remember on the flight plan, the first officer copied this, 870 from the OPT. So the OPT gave an engine out acceleration height of 870. That's above sea level. So you have to subtract the field elevation for Dubai, which is 62. So 870 minus 62 is 808. So that's how we came up with 808. These figures are above ground, remember that. Now we go to previous page, and from the OPT, the first officer enters flaps 1. From the OPT, enters 22.7, and he pauses, and at this point goes back to the flight plan data. And he actually records that 5.75 stab trim at this point. Now, when they were reading the 870, remember height above sea level from the flight plan, which was from the OPT, that's a good time to pause, and the captain would now set it on his minimum selector on his PFD, and the first officer at this time would do the same. That's a good time that I suggest that it be done. All right, so let's go back to the page 1. And now the first officer will read off the speeds from the flight plan. V1 156, V2 158, or I should say VR 158, and V2 161. And that's what was directly on those figures we read from the, we'll go back and just check that again, that we read here, 156, 158, and 161. So we put those in directly into the CDU, which is correct. All right, now that data is complete. Going to the index and approach and check the VREF 40 and record that on the flight plan 151. Well, let's go back to the flight plan and see where he would record it. So that would be recorded here. That's a little typo. So that would be 151. The weight's changed. So 151 is what that should be. So he would record 151. Which is flaps 40. Speed, the weights are changing here as we are sitting here. In any case, the next item would be to the climb page and 250 knots at 10,000 feet above airport elevation for a speed restriction, confirm it and then execute. And then at the very last item of the performance would be to the MCP, and the captain would make sure, and the first officer would monitor auto throttle on, it is, and V2 speed of 161. VNAV, push, bar light, and VNAV armed. LNAV armed, bar light, LNAV armed. Performance complete. Thank you. See you in the next video.